You had a tail. This is not a metaphor. About 5 weeks after you were conceived, you, the actual you, had a tail. It stuck out. It had bones in it. It wiggled. And then your own body decided it didn't like it and killed it. Cell by cell, your body executed your tail, absorbed the evidence, and left behind a stump that is still inside you right now. Reach behind you, at the very bottom of your spine, that hard little point at the end, that's it. That's the leftover. 3 to 5 vertebrae, fused into a nub, sitting exactly where a tail is supposed to start. So here's the thing that should genuinely bother you. Every monkey has a tail. Your ancestors had tails for tens of millions of years. Tails are useful. They're a fifth limb, a balance pole, a grappling hook. And then, around 25 million years ago, one group of primates just deleted it. And that group is us. So what happened? What could possibly be worth throwing away a perfectly good tail? The answer is one of the strangest things in your entire genome. A piece of genetic junk that jumped into the wrong place at the wrong time and permanently changed what a human being looks like. And it may still be hurting babies today. Let's start with the fact that you didn't quite lose it, because your tail is still in the blueprint. The instructions are still there. They just get canceled halfway through. Here's what actually happens. About 4 to 6 weeks into a human pregnancy, the embryo grows a tail. A real one, sticking out past the legs with its own vertebrae. At that stage, if you looked at a human embryo next to a cat embryo or a mouse embryo, you would struggle to tell them apart because they all look like the same little curled shrimp with a tail. Then, around week 8, something brutal happens. The tail stops growing, and a wave of programmed cell death sweeps through it. Scientists call it a burst of apoptosis. Your body has a self-destruct instruction aimed at a body part, and it fires it. The tail cells are told to die, and they obey. The tissue is broken down, reabsorbed, recycled into the rest of you. What's left is the coccyx, your tailbone, 3 to 5 vertebrae fused into a hard little triangle. So you're not a creature that never had a tail. You're a creature that grows one and then destroys it every single time in the dark before anyone can see. Which raises an obvious question. Why go to all that trouble? Why build it just to demolish it? To answer that, you need to know exactly where in the family tree the tail disappeared, because it's the single cleanest dividing line in the primate world. Here's the rule of thumb people get wrong constantly. Monkeys and apes are not the same thing, and if you want to tell them apart in 1 second, don't look at the face, look at the back end. Monkeys have tails, apes don't. Chimpanzees, gorillas, orangutans, gibbons, bonobos, no tails. And us, that's the whole club. The apes, the tailless ones. Now wind the clock back. Around 25 million years ago, there was a population of primates in Africa living in trees with tails, minding their own business. And that population split. One branch carried on being monkeys, and their descendants still have tails today, swinging through the canopy. The other branch became the apes, and in that branch, something happened to the tail. Not gradually, over millions of years of it shrinking inch by inch. The genetic evidence points to something much more abrupt. Something broke, and for a long time, that was the frustrating part of this story. We could see exactly when the tail vanished, and we had absolutely no idea how, until a graduate student hurt his back. This is my favorite part because the discovery is so human. A geneticist named Bo Xia injured his tailbone, and while he was sitting there in pain, doing what any of us would do, he started thinking about the stupid little bone that was hurting him and wondering why it was even there. Why do we have a tailbone and no tail? So he went looking, And instead of doing what everyone else had done, hunting for a broken gene, a typo in the code, he looked somewhere nobody was looking, in the junk. Because most of your genome is not genes, only a small fraction of your DNA actually codes for proteins. The rest is a vast, weird, sprawling landscape of repeats, leftovers, and this is the good part, genetic parasites, little stretches of DNA whose only function is to copy themselves and paste themselves back into your genome, over and over, like a chain letter that's been running for 100 million years. They're called transposons, jumping genes. Your genome is absolutely riddled with them, and one particular family, called ALU elements, has copied itself into human DNA over 1 million times. Most of the time, they land somewhere harmless and nothing happens. But sometimes one lands somewhere that matters, and about 25 million years ago, one of them landed in exactly the wrong place. The gene it landed in is called TBXT, and TBXT has one job that matters here. It helps build the tail. It's a master switch in the embryo's tail bud, and versions of it show up across the animal kingdom doing the same thing, telling the body how much tail to make. Now, here's the crucial detail, and it's beautiful. The ALU element did not land in the middle of the gene and smash it. If it had, the gene would just be broken and you'd probably be dead. TBXT does other important jobs too. Instead, it landed in an intron, one of the spacer sections that gets cut out when the gene is read. Harmless, in theory. Except there was already another old ALU element sitting nearby, facing the opposite direction. And two ALU elements pointing at each other do something specific. When the gene is read out, that stretch of RNA folds back on itself and loops, like a shoelace pulled into a knot. And when the cell's machinery hits that loop, it gets confused, skips over a chunk of the instructions, and stitches the ends back together. The result is that this one gene now produces two different versions of the protein. The normal one, build a tail, and a new, shortened one. And when both are present in the embryo's tail bud, the message comes out garbled. Build a tail. Sort of. Actually, don't. So, nice theory, but how do you prove that a random piece of junk DNA is the reason you don't have a tail? You do the obvious, insane thing. You go into a mouse, an animal with a perfectly good tail, and you paste the human version of this glitch into its genome. And in 2024, that's exactly what a team at NYU published in Nature. They engineered mice to produce both versions of the protein, the way apes do. And the mice were born with shortened tails, some with no tail at all. The exact effect depended on how much of the short version was made. More of it, less tail. They had reproduced, in a living animal, the thing that happened 25 million years ago. A single jumping gene insertion and a tail disappears. And I want you to sit with how absurd this is for a second. There was no grand evolutionary plan, no slow, dignified march toward the human form. A parasitic scrap of DNA, a molecular chain letter that does nothing but copy itself, pasted itself into a random spot, folded a piece of RNA into a knot, and rewrote the shape of every ape that would ever live. Including you. You are tailless because of a typo, but hold on, because a typo alone doesn't explain it. Mutations happen constantly, and almost all of them go nowhere. For this one to spread through an entire lineage and stick for 25 million years, losing the tail had to be worth something. So what was it worth? And here is where I have to be straight with you. This is the part we have not solved. We know the mechanism, we know the gene, the insertion, the splice, the year, roughly. We do not know for certain why it won. That's the honest state of the science, and anyone who tells you otherwise is selling something. But there are good ideas. Start with what a tail is actually for. For a monkey running along the top of a branch, the tail is a balance system. It's a counterweight. Swing it one way, and your body rotates the other. Experiments on squirrel monkeys show that when the tail is reduced, they measurably struggle to balance on narrow, wobbly supports. Up on top of thin branches, a tail's not decoration, it's survival equipment. Now change the body plan. The early apes got bigger and heavier, and they stopped running along the tops of branches. They started moving underneath them, hanging, reaching, swinging arm over arm, climbing vertically. And once you're hanging below a branch by your arms, a balance pole is close to useless. You're not balancing on top of anything. Your grip is your safety, and a tail isn't free. It's bone, muscle, nerves, and blood to grow and carry around. So the leading idea is that the tail went from essential equipment to dead weight. And when the glitch showed up, nothing stopped it. Maybe because there's a cost to this that nobody expected. Here's the twist that turned this from a fun evolution story into a medical one. When the team engineered those mice, they found something else. The mice expressing the shortened version of the protein had a higher rate of neural tube defects. The neural tube is the structure in an embryo that becomes the brain and the spinal cord. It has to zip itself closed at the right time in the right order. If it doesn't close properly, the result is a serious birth condition. Spina bifida is the one you've probably heard of, and it's not rare. Neural tube defects affect roughly 1 in 1,000 newborns. Now, I have to be careful here, because this is a proposed link, not a proven cause. The researchers themselves raised it as a possibility, and it needs a lot more work. But the possibility is this: the same genetic accident that took our tails may have left a permanent fault line in how the human spine closes. A 25-million-year-old glitch, still charging interest. Evolution doesn't optimize, it doesn't clean up. It takes whatever works well enough to reproduce, and it lets you carry the bill. And sometimes, the bill is due on a baby. Which brings up the thing everyone always asks: are babies ever born with tails? And the answer is yes, but it is not the answer you want it to be. In the entire medical literature, across more than a century and multiple languages, researchers reviewing case reports have found on the order of 200 cases. So it happens. But here's where the internet gets it very wrong. These are usually not a charming evolutionary throwback, not proof that the old code briefly switched back on. In most documented cases, that appendage is associated with spinal dystrophism, the spine not closing completely. It's a birth defect. It needs imaging, and often surgery, because of what it can indicate about the spinal cord underneath. So it's not a party trick, and it's not a window into our ancestors. It's a child who needs a doctor, which honestly makes it more interesting, not less, because it points at the same fault line. The tail program, the closing of the spine, and the accident that links them are all tangled together at the bottom of your back, which leaves one last question. That nub you're left with, is it just garbage? A useless souvenir? Not even slightly. Your coccyx is doing a job right now. Those fused vertebrae are an anchor point. The pelvic floor muscles attach there, and the pelvic floor is what holds your organs up and keeps you in control of your own body. Your glutes attach there too. And when you sit down, your tailbone acts as one leg of a tripod, sharing your weight with the bones of your pelvis. That's why landing on it hurts so much, and why an injured tailbone can quietly wreck your posture and a lot more. Evolution didn't delete the tail, it repurposed the ruins. So, zoom out. 25 million years ago, a piece of parasitic DNA copy-pasted itself into a gene it had no business being in, folded an instruction into a knot, and took the tail off an entire branch of the primate family. Every ape alive is living with that edit. You grow a tail in the womb and kill it. You carry the stump for life, holding your insides up, and you may still be paying for it in ways we're only starting to understand. You're not a creature that never had a tail. You're a creature that lost one and kept the receipt. And if you want more of these, there's a whole universe of why waiting. Subscribe, and I'll see you at the next one.